First theorem of this chapter 7.1. This theorem is angle side angle congruency rule. Two triangles are congruent if true angles and the including side of one triangle are equal to two angles and the included side of the triangle. Here are the two triangles ABC and DEF. These two triangles are congruent by angle side angle. Here the given condition is triangle ABC and triangle DEF. This is triangle ABC and this is triangle DEF. These triangles are congruent by angle side angle congruency rule. It means in these two triangles, angle B is equivalent to angle E, angle B is equivalent to angle E, BC is equivalent to EF, and angle C is equal to angle F. This is a given condition here. To prove, I have to prove here triangle ABC is congruent with triangle DEF. So here arises three cases. Case number 1, if we suppose that AB is equivalent to DE, then we have to prove the congruency of these two triangles. If side AB is equivalent to DE, then in triangle ABC and DEF, AB is equal to DE by supposition, angle B is equal to angle E, given condition, BC is equal to EF, this is again given condition. Therefore, these two triangles are congruent by side angle side congruency rule, SAS. This is the side, this is the angle, and this is again side. Now the case number second is if AB is greater than DE. This is the second case. If AB is greater than DE. So we have to do the construction. We have to take the point P on AB such that this PB is equivalent to DE. If AB is greater than DE, then we have to take the point P such that BP is equivalent to DE. Then again we have to prove the congruency of triangle PBC and DEF. So here PB is equal to DE, supposition, angle B is equal to angle E, given condition, BC is equal to EF, again given condition. Therefore, these two triangles are congruent. Triangle PBC is congruent to triangle DEF. So by CPCT, if these two triangles are congruent, then angle PCB means PCB is equivalent to angle DFE. This is CPCT. But we have a given condition here. Angle ACB is equivalent to angle DFE. This condition is given. When we combine these two conditions, PCB is equivalent to DFE, ACB is equivalent to DFE, then these two triangles are equal. This implies that ACB is equivalent to PCB, means ACB is equivalent to PCB. This is only possible when the point P coincides with A. When point P coincides with A, then angle ACB is equivalent to PCB. This is possible only if P coincides with A, and this implies if these two sides coincide with each other, it means AB is equivalent to DE. Then after we have to prove that ACB is congruent with DEF as we have proved in case first. So this gives us the congruency of ABC and DEF. Similarly, we can prove third case third. Suppose first case is let AB is equal to DE. Second case is if AB is greater than DE. Then third case is if AB is less than DE. Similarly, you can prove that in this way, you can prove that if AB is now less than DE, then we have to take the point P outside the AB. Here we have to take the point P. Now join this to C. This is A and this is B. Similarly, as we have proved case second, you can prove case third also. So we can write here similarly, triangle ABC is congruent with triangle DEF.